Welcome back to another course. In this course, we will talk about the fundamentals of Python programming language. At the end of the course, you are going to be ready to write your Python programs with the fundamentals you learned in this course. This course is going to be completely beginner friendly. We are going to start by installing the Python and our code editor, and we are going to finish the course with the classes and the object-oriented programming. So, if you are just starting to learn programming or Python, this course is a great place to start. Here I am at the python.org. You can download the Python from here. From just visiting the download section, you can just select the package you want, like you can just press download Python and then you're ready to go. Don't forget to get the download button for your operating system from here. For example, if you are using Windows, you need to select the one with Windows. And this is our second place, our code editor. If you're just learning Python, I recommend you to use this code editor, but you can try others too, but I'm going to be using the Visual Studio Code in the course. So if you download this and use this in the course, it's going to be really good for covering everything in the course. From here, code.visualstudio.com, you can just press download and download this code editor. And after that, you are going to be ready to write your Python programs. And we are going to jump on the code editor right now. So here we are at our screen that when we install the code editor, we downloaded. So from here, you can just visit here, extensions. And then from here, you can install Jupyter, Jupyter Keymap, Jupyter Celtex. They are going to be installed automatically. If you just install the Jupyter, we are going to use a Jupyter Notebook on this Python course. Also, you can download the Python and Pylance from here. And after that, you are going to be ready to go. We can just close this extensions page. After that, what we are going to do is we are going to open this page in here. Like I'm just going to click on it on the Explorer. And after that, here is our file base. Like from here, by right clicking or using the upper buttons, I can create files from here. Like I'm going to say right click and then I'm going to choose new file. And I'm going to say first file.py. So here is a Python file. You can create a Python script from here, like you can just write code, you can say blah blah blah, and after that you can just run everything in the file. But in the course we are not going to use that. We have a special file format which is called Jupyter Notebook, which enables us to run cells instead of the full program. Like what I meant by cells, I'm just going to show you. We are going to create another file like notebook.ipynb. And after creating this, you can see an automatic cell came up. And we can just close the other two, like I'm just going to say don't save. I will close the welcome one and I'm just going to delete this since we are not going to use that. And let's talk about the Jupyter Notebook. In Jupyter Notebooks, you can just add code cells like this and write programs separately, and you can just run them cell by cell. So you can do a lot of things by not running the entire program, which is going to be quite useful in data science and Python programming. This is going to be a course for Python development, and also it's going to be a base for a data science roadmap. So whether you are trying to learn Python or you are trying to learn data science, this is a great point to start. After learning the Python, you can just learn other things, like you can just learn web development, data science, and extend your knowledge in that areas. You can do game development, you can do cybersecurity, etc. You have a lot of options. Great, now I'm going to delete this code cells, and from the right side I will select a kernel from here. I will say Python environments, and I'm going to select the Python, the most up-to-date version, like this. And we are going to write our first code right now. It's going to be our first program. We will say print, and we are going to say welcome to the course. And I'm just going to run that. If you are using Windows, you can just press Shift and Enter for running the cell and getting a new one. If you are using Mac, you can just press Command and Enter and you can do the same operation. And in here, we just said print and we use the print function for printing something to here. We displayed the welcome to the course in the screen. Another thing we are going to cover is going to be the comments. You can just use the hash character and add like this is a comment, and you can just run this. A comment doesn't affect your program, and it just helps other developers or the ones that you read your code to understand the code better. Like after this print statement, I can just add a comment like, here I added a comment, and after that when I run this, you're going to see it's not going to display this line here because it can be seen only in the development side. Okay, I'm going to show you a feature of the Jupyter Notebooks. I'm just going to come in here and I will select the markdown, and after that I'm going to say this is my first markdown, and I'm just going to run this one. And here you can see that I displayed a text in the place that I want, and I can use the markdowns like this for adding comments on the Jupyter Notebooks. By the way, following the course by coding, like writing the codes with me, is going to be really helpful on your learning process, and I highly recommend it. If you just see on the screen and don't write them on your code editor or a notebook and anything, if you don't write them, you are going to forget them. But if you write them and do practices by yourself, you are going to learn better. Great, now we will talk about variables and data types. Let's start with the basics. In Python, a variable is like a container that holds data. You can think of it as a label attached to a value. Variables allow us to store and manipulate data in our programs. With variables, also I will show you the type function, just like the print function, which is going to help us on seeing the data type of a variable. Let's say name, and after that for defining a variable I will use a equal sign, and after that I'm going to say my name like honor in quotes. We are going to cover the quotes after this, and I'm going to say type name, and we are going to see that we will get a string in here. So for creating a variable, I will use a name, and after that I'm going to say equal sign, and after that it can be like integer, like I will say age, and after that I'm going to enter my age after that. And when I do that, when I call the age here, I'm going to get the data type of integer right now. The important thing in variable defining is entering a name, and after that using an equal sign. So let's do more examples on this. I'm going to say height, and I'm going to say 185, and I'm just going to run this, and I will call the type of this, and it's going to be a float in here. Let's do one more, like is student, and it's going to be no. So when I define this, it's not going to give error because we don't have something like no, but we can just say false instead of no. We are just going to cover the booleans after this. I'm going to say is student type in here, and it's going to be boolean. Instead of yes or no, we have true and false in Python. In these examples, we have declared 4 variables: name, age, height, and is student. Each variable has a specific data type: string, integer, float, and boolean. Now we are going to talk about them. We will start with string. The string data type is used to represent text. Strings in Python are enclosed in single or double quotes. So let's do an example with strings. I will say like name again. I'm just going to use single quote, and after that I will say honor. And we are going to see that it's going to be string again. And after defining this, I can use this string in a function like I will say name like this, and it's going to print honor. So what it does is it stores this string in name variable, and after that when I call the name in anywhere in my program, it will return honor for that. Also, you can define strings with double quotes, like let's say message, and after that I will say if you like the course, please like the video and subscribe. And I'm just going to say print message. I will just use it in a function, and it's going to print the message. In this example, we have created a string variable named message, and we just printed it. Strings are versatile and can represent anything from simple words to entire paragraphs. Let's talk about integers. Integers are used to represent whole numbers without any decimal points. They can be positive, negative, or 0. So let's say number is going to be 25. And here it is when I call the type number, we will get the 25. And when we print the number, here it is. So when I call the type of the number, it's going to return integer. When I print the number, it's going to return 25 because I just defined a variable as number with the value 25. Also, you can just do minus 25, and after that you will get a negative number printed in here. You can just change the variables like this. Like I just wrote minus 25 in number and it updated to minus 25. And after that, if I say number equals to 0, and if I print the number again, we will see that it's going to print 0 instead of minus 25 because we just updated it. Integers are commonly used to represent quantities, counts, or any situation where only whole numbers are relevant. Great, let's talk about floats. The float data type is used to represent numbers with decimal points. Floats are suitable for situations where precision matters. Like let's say height again, and let's say 6'3", 6'4", doesn't matter. And after that I will say type height, and we will get the float in here. And I'm just going to print the height like this. And after that I'm going to see that 6.4 is displayed on the screen. Again, you can use like minus like this for getting negative floats. And you can just use 0.0 for getting something like 0. Here it is. I'm just updating that and running the print statement again. So let's just change this to 6.4 again. And I'm just going to show you a thing like we said print height and it's 6.4. But what we can do with print functions is we can use multiple variables or multiple things together in print functions. Like I will say print and I will say height. After that I'm going to add a comma to here, and after that I will say height. So it's going to print height and 6.4 together. So what else you can do is you can just say height string, and you can just say height. You can define a string like this, and after that you can just say print height string, and after that you can use comma, then you can say height. And you are going to see that it's going to run perfectly. Okay, let's keep with the floats. Floats are crucial when dealing with measurements, calculations involving fractions, or any scenario requiring decimal precision. Great, let's talk about booleans. Booleans are used to represent truth values, either true or false. You can think them like yes or no, but in Python we have true and false, not yes or no. They are fundamental for making decisions in your code. Like let's say, is Python great? And I'm just going to say true. After that I will just type the is Python great? And here we get the boolean. So let's print this with the feature we just learned, like is Python great? And I will say is Python great after that, and we will see that is Python great true in here. Also you can delete this and print this by itself. It will print true like this. Booleans are essential for creating conditional statements and controlling the flow of your program. Great, we just learned variables and data types. We have some rules and common use types on variable naming, so let's talk about them. One of the golden rules of variable naming is to use names that are meaningful and descriptive. This makes your code self-explanatory, reducing the need for comments. So let's do an example like name, and let's set this like Clark, and let's say age is 35, and let's say is adult, and it's going to be boolean true. So these variable names clearly convey the purpose of each variable, making the code more understandable. Okay, let's come to the Python's rules on variable naming. We can't start with a number or symbol when we are defining variables. Like I can say 3 variable and it can be like 40. It's going to raise an error. One of the golden rules of variable naming is to use names that are meaningful and descriptive. This makes your code self-explanatory, reducing the need for comments. So let's do an example like name, and let's set this like Clark, and let's say age is 35, and let's say is adult, and it's going to be boolean true. So These variable names clearly convey the purpose of each variable, making the code more understandable. Okay, let's come to the Python's rules on variable naming. We can't start with a number or symbol when we are defining variables. Like I can say 3 variable and it can be like 40. It's going to raise an error. But if I just delete this, it's going to work smoothly. So we can't add numbers. It's same for the punctuation, like minus variable is going to return error. Also underscore variable is going to raise an error. We can't use any symbols in variable naming, like I can say event name and I can just say like basketball match. It's going to raise an error. But with one exception, that you can use underscore in variable naming. Like you can say event and name with underscore and you can just say basketball match. And if you do like this, you are not going to get an error. You are going to create your variable successfully. This is only for the underscore. Also, we have another rule, like be cautious not to use reserved keywords as variable names. Like print was a reserved keyword. It's a function's name in Python. Doing this can lead to unexpected behavior and errors in your code. Like if I try to print and if I just define a variable like print and I say basketball match, and if I just run this, it's going to work smoothly. But when I call the print function, I can have some problems like here. I can't use the print function like this. I will say Python is great in print function. But what happened is we can't use the print function because we defined a variable like this. So try not to do that. But how are you going to change this? From here, you can just say restart. But before that, you are just going to delete these cells. Like I will delete this one. And when I press the restart in here, and I will say restart. And after that, I'm going to say run all. And you will see that it's going to be stuck on the errors. Like we have errors in here, and run the others. It's going to run our runtime, every cell, and it's going to stop at the first error at this place. So I'm just going to pass them, and I will come to here. We can see that our print function's name is changed, like the color of it changed, and now I can use the print function safely. If you did something like we just did, you can just press restart and you can say restart for restarting the kernel. And after the restart, you can just do things again without the problems. Like you can just use the print function again. So again, we have a function named print in Python. So not using it as variable name will be a good practice. Let's talk about common naming practices. When naming variables, there's 2 common methods and they are called snake case and camel case. This convention ensures consistency across your code base. Snake case gets used like lowercase letters and underscore between the words like this. And the camel case is like uppercase letters for the first letter of the words, like camel case. And we can just say 40, for example. From here, we can see that we use underscore and lowercase letters on snake case, and we capitalize every first letter for word in camel case. Great! Let's talk about arithmetic operators. Arithmetic operators allows us to perform mathematical operations in Python. These include addition, subtraction, multiplication, division, and more. Let's define 2 variables like number 1 as 10 and number 2 as 5. And let's start with addition. Let's say addition is going to be equal to the number 1 plus number 2. So if we print the addition's value, we will see that it's going to be 15. Also, in a print function, you can just do 10 plus 5, and after that you will see that it's going to print 15. Let's do subtraction. We will say subtraction is going to be 10 minus 5, which we can also do with variables like number 1 minus number 2. And if you print its value, it's going to be 5. Great! Also, I want to show you that in normal Python scripts like the .py extension files, you can just print something with writing print function. But in a Jupyter Notebook, if you just write the variable's name like this, you will get its value like you write the print. You don't need to use print every time. Great, so let's get the multiplication right now. We will say multiplication, and it's going to be equal to number 1 multiplied by number 2. And let's see its value. From now on, I'm not going to use print in the most of the topics, and I will just write the variable name. Let's also do division. We will say result division, and it's going to be like number 1 divided by number 2. And let's get the result division. Also, you can do an operation like 10 divided by 5, like strictly like this, and you will get the same result. Since we are in Jupyter Notebook, we don't need to write the prints in the most of the scenarios. Great, so let's talk about exponentiation. We will say exponentiation, and it's going to be number 1 power number 2. And let's see what's its value like. As you can see, 10 with power 5 is going to be 10,000. Great, so in these examples we have covered various arithmetic operations using two variables, number 1 and number 2. So let's talk about the order of the operations. It's crucial to understand the order of operations, often remembered by the acronym PEMDAS. P-E-M-D-A-S, and it's like parentheses, exponents, multiplication and division from left to right, and addition and subtraction. I want to write this for clear demonstration, like parentheses, exponents, multiplication and division left to right, and also addition, subtraction from left to right. Also it needs to be like division. All of these are left to right. Let's do an example like PEMDAS. I just read it like PEMDAS, but I'm not sure how it's read, and I will say number 1 plus 3, and let's multiply this with number 2, and let's divide this like with 2 and give the power of 2, and let's see our result. In this example, we have used parentheses to enforce a specific order of operations. The result is calculated following the PEMDAS rule, ensuring that multiplication and division take precedence over addition and subtraction. Python also provides augmented assignment operators, which offer a concise way to perform arithmetic operations and update the value of a variable. Let's see how they work. So let's go like, let's set 0 to total, and then let's use total plus and equal sign together, and let's say 5. This one is going to make our total 5. It's pretty same, like I'm going to add here as comments. I will say total equals to total plus 5. These both are same, like this one and this one is completely same. Let's do like total minus equal sign 2, and let's see the value of total in here. It's going to be 3, and it's same as total minus 2. These are same. So let's do a multiplication like this, total multiplied equal sign 3. Also it's equal to total multiplied by 3, and let's see the value of this like 9. Great. In these examples, we have used the plus equal sign, minus equal sign, and multiplication symbol equal sign operators for augmented assignments. These operators offer a shorthand way to update the value of a variable based on its current value. Okay, let's talk about comparison operators. These operators allow us to compare values and make decisions based on the results. Let's explore the different comparison operators available in Python. Let's firstly talk about the equality operators. It's going to be double equal sign and exclamation mark with equal sign. The equality operators allow us to check if two values are equal or not. So let's say like x is going to be equal to the 5, and let's say y is going to be equal to 10. So let's check like if x is equal to y. So let's say like result 1, and it's going to be equal to the x equals to y. Also we can add parentheses to this. It will both work. I will just show you both. When I run this, when I get the value of this, we are going to see it's false. It returns a boolean. We can also check its type like type result 1, and we are going to see it's a boolean. So let's just delete this type thing, and I'm going to show you if I remove the parentheses, it's going to be the same. So I will just update this one and update this one. This checks if x is equal to y. So great. So at another step, we will see that result 2 is going to be x exclamation mark equal sign, and we will say y. Also we can't add space to there, and I'm just going to run this, and I will say result 2 in here. So it's true. This is like if x is not equal to y. Also you can add parentheses if you want. It's not necessary, but you can do that, and it will work in the same way. In this example, we use the equal to operator to check if the value of x is equal to the value of y. We also use the inequality operator to check if x is not equal to y. Okay, let's talk about relational operators like greater, less than, less or equal to, greater or equal to. Relational operators helps us compare the magnitude of values, whether one value is less than, greater than, less than or equal to, or greater than or equal to another. So let's say like A, and let's say 15 for this, B, let's say 20 for this, and let's check if A is less than B, like let's say result 1 again, and I'm going to say A less than B. So let's print the result 1. True, 15 is less than 20. Great, let's check if A is greater than B. So for that we will say result 2, and I will say A, and then I will say B. And let's print the result 2. It's going to be false, like this. And now we are going to check if A is less than or equal to B. So for that I will say result 3, and I'm going to say like A is less than or equal to B. So I will just get the result 3 in here. It's going to be true. Also you can directly do like less than or equal to B instead of assigning to a variable, but I'm just assigning them to a variable for this to be more informative. So let's check if A is greater than or equal to B. So for that we will say result 4, and it's going to be like A greater than or equal to B, and it's going to be false. Great. In these examples we use the relational operators to compare the values of A and B in various ways, checking if one is less than, greater than, less than or equal to, or greater than or equal to the other. We can chain multiple comparison operators together to create more complex conditions, like let's say number, and let's set it like 25, and then we can say result again, and it can be like 10 less than or equal to, number less than or equal to 30. So we have two conditions in here, and let's get the result. In this example we use a chaining of comparison operators to check if the value of number is between 10 and 30. This is a concise way to express multiple conditions. So let's see object comparison. The is and is not operators are used to check if two objects reference the same memory location. Let's say variable 1, and let's set 10 to this, and let's say variable 2, and let's set 10 to this too. So we can say like result 1 can be variable 1 is variable 2, and let's get the result of this, like result 1. It is true since they have the same value, and we can just use is not same like this, result 2, and it's going to be variable 1 is not variable 2. And let's get the result 2 in here, like we have false. In this example we create two variables, variable 1 and 2. The is operator checks if both variables reference the same object. while is not checks if they don't. Great, now we are going to turn back into strings and we will talk about the string methods. Let's redefine strings. Like strings in Python are sequences of characters, and Python provides a rich set of tools for working with them. So let's create a string variable like greeting, and it's going to be like hello. And after that, what we can do is also let's say like hello Python. And what we can do now is let's see some basic operations. Like we can get the length of this like length function we have in Python. It's a built-in function, and we can say length greeting, and it's 14. This 14 here is the character count, like 5 in hello, 6 space also included 7, 8, 9, 10, 11, 12, 13 and 14. We have 14 in here. We can access to individual elements. Like if you want to access to the first character, we need to say greeting and we need to say 0, because in Python indexes start from 0. Like if you want to reach the first one in all of the scenarios, you need to write 0. So the first index is going to be 0 and the second one is going to be 1. Like is h in here is index 0 and this e in here is the index 1. So if we want to reach to the last character, we need to say greetings, variable name, then we need to open brackets and we need to say 13 since we started with 0. So we are going to have this mark in here. Also, how we can do that is we can just say greeting and say -1 inside of this bracket. And if we do that, we will reach the same result. It will just go from here, this h to left, and take the first one if we say -1. If we say -2, it's going to give us the n. Like this. Great. So it's like the same for the others. If you want to access to element of a, I'm not sure if I talked about it yet, but for a list, tuple, etc., you are just using the variable name and you will add brackets, then you will give the index number. If I didn't talk about the list, tuple, etc., that kind of things, it's just coming in the, I'm thinking like 5 or 6 minutes of this course, and you will see that. You can also slice the strings. Like let's cover string again, like the greeting. Let's say we want to get a substring like 7th character to 13th. And here it is, Python. Let's say if you want to get the exclamation mark too, we can say 14 in here. Great. We can add strings together. Like we can just say greeting and we can say plus arithmetic operator and we can say welcome. And it's going to work smoothly, like it's going to be like hello Python welcome. You can do that in a print function like greeting plus, let's give it an empty string for a space, and we can say welcome. And here it is, our result. But one important thing in here, you can't add numbers to here. If you're adding strings, all the types needs to be string. Like it's going to raise an error. But if I give this 25 like in a string format, not integer, it's going to work smoothly. Like this one in here is not an integer, it's a string. You can also just check the type of this from here for making sure it's string if it's written inside the code. In these examples, we have covered various basic string operations. We have calculated the length of the string, accessed individual characters using indexing, sliced the string to create a substring, and concatenated strings together. Python provides a variety of built-in string methods that make string manipulation more efficient and convenient. Let's explore some of them. So let's create a string again, like sentence is going to be like Python is an amazing programming language. And what we can do is we can change the case like sentence.upper method in here. We can see that all the letters are uppercase, and we can do like sentence.lower for getting them all in lowercase. We can find substrings like sentence.find method in here, amazing. And we can see its index, it's going to be the starting point of its index like 6, 7, 8, 9, 10, 11, 12, 13. And from 13, here is amazing. Great. Also see that after the dot, I can use the methods like from the variable name, and using dot, I can use the upper method in here. You can do that too. You can try different methods like sentence, dot, and after putting dot, you are going to see the list of methods in here, and you can just try different things from here. Let's see replacing. So we can say replace, and after replace, we need to give like, let's say we want to change the amazing with powerful. And when we run this, you are going to see that Python is a powerful programming language. Also, this sentence is not modifying the original variable. Like if I call the sentence again, we are going to see that it's going to be a Python is an amazing programming language. So what we need to do in here is, if we want this to be our original sentence, we just need to do an assignment, like we need to say sentence and we need to reassign the variable like sentence.replace amazing with powerful. And if we do that, you are going to see if we call the original sentence variable, it's going to be changed to powerful. So what we did in here is we just reassigned the sentence with this equal sign. Also, we can count the occurrences, like we can say sentence and we can add dot and we can use the count method, and we can just give the I in here like this, and it says 2. Let's check them, one in programming and one in is. In this examples, we have used various string methods like upper, lower, find, replace, and count to manipulate the string sentence. These methods offer powerful tools for working with text data. Let's talk about string formatting. String formatting is a powerful feature in Python that allows us to create dynamic and readable strings. Let's explore different ways to format strings. Let's say name, and it can be like Jack, and let's say age, and it can be 30. So we can use f strings. What are they? We can say formatted string, and for creating a f string, we just need to add f before the quote. So I'm just going to create a normal string like this, and I will say hello, my name is, and after that, if I use curly braces, I can insert variables, like I can say name, and I will say I am curly braces age years old. And I'm just going to set this and call formatted string. It's going to return hello, my name is Jack and I'm 30 years old. What if we don't put this f or curly braces? It's not going to work like that, and we can't get this in that scenario. So if you want to use f string with curly braces, it's a really nice method for string formatting. Also, we have another one, the format method, like we can say formatted string 2, and it's going to be hello, my name is empty curly braces, and I am empty curly braces again, and years old. But after this string and we will say dot format, and we will pass the name and age with the order we want to create. So if I call the format string again, it's going to say hello, my name is Jack and I'm 30 years old. But this order is really important. If you just say age and name, it's going to mix them up and it's going to give something different. So we don't want this. So we need to take care of this order in here. Name, age. Now it's cool. Great. In these examples, we have demonstrated two common ways of formatting strings, f-strings and format method. These techniques allows us to insert variables into strings for dynamic content. Great, let's talk about conditional statements. Conditional statements are a fundamental building block of programming. They allow our programs to make decisions based on certain conditions. Let's start with basic if statement. So our keyword is if in here. Let's set age to 25 and we will say if age is greater than or equal to 18, print you are an adult. And when I'm just making this work, it's going to print that you are an adult. But it's working because this condition is satisfied. This is true. Like I'm just going to run this in here and it will return true. But what if it not? So I can just change the age in here to 15 and it's not going to work in this scenario. It didn't print anything. So, okay. In this example, we have used an if statement to check if the variable age is greater than or equal to 18. If the condition is true, the indented block of code is executed, printing you are an adult. What if that condition is not satisfied? We have the keyword else for that scenario. So let's say like age is going to be 15 this time, and we will say if age is greater than or equal to 18, print you are an adult. And we will say else right now. We don't need to give any condition to here. We can say print you are not an adult. So what this does is it checks this condition, it passes it since it is not satisfied in here. After that it comes to here. We don't need to specify any condition in here, and when I run this you will see that we are going to have this else block worked. Sometimes we need to check multiple conditions. This is where the elif, which is the combination of else and if statement, comes in play. So let's say like temperature is 28, and we can say that if temperature greater than 30, then print it is a hot day. And we will say now else if elif 20 less than or equal to temperature and less than or equal to again 30, print the weather is pleasant. And we will say else, and it's going to be like print it is a cold day. And here we can see that it's catched by this else if block right now. It checks for the first if, then it passes, it gets caught in the second if, so it doesn't print it's a cold day. If we just delete this, you will see that it's going to print the else block we have, but if we just insert this, it's not going to, because it's going to be catched from this. In this example, we have used elif to check multiple conditions. Depending on the temperature, the program will print different messages. Conditional statements can also be nested, allowing us to create more complex decision-making structures. Like we can say is raining, and it can be like true, and we can say is cold, and it can be like false. So let's say if is raining, print bring an umbrella. And we can say if is cold, then we can say print wear a jacket too. So it's only going to work if this if condition is satisfied. It means that it is true. Like if we assign true to this, like in here, it's going to work. And what we can do is we can say else, and we can say print enjoy the day. So it only printed bring an umbrella because this one worked, this one didn't work because this condition is false, and it didn't get caught from else because it get taken by this if. Like this else is connected to this if statement. In this example, we have nested if statements. If it's raining, the program advises to bring an umbrella. If it's cold as well, it suggests wearing a jacket. If it's not raining, it encourages enjoying the day. For simple conditions, Python offers a concise ternary operator. Let's explore how it works. It's going to be a one-liner, like we can say age 21, and after that we can say you are allowed. If age is greater than or equal to 18, else you are not allowed. And it's going to give you are allowed. And we change this to 10. It will say you are not allowed this time. And if we change this to 50, for example, it's going to say you are allowed. So in this example, we have used the ternary operator to assign a value to the variable message based on the condition. It provides a concise way to express conditional statements. Let's talk about for and while loops. We will start with while loop. No, let's start with for loop. I'm going to start with for loop, not while. The for loop is used when we want to iterate over a sequence, a specific number of times. Let's start with a basic example. I'm going to create a list like fruits, and it's going to be apple, banana, and I will say cherry. So after that, I'm going to create my for loop like for fruit, in fruits, print fruit. So how this works is, for every element in fruits list, like for apple, banana, and cherry, it's going to iterate 3 times. It's going to print the element. Like you can just change this fruit as index, whatever you want, but you want to use you need to use the same thing inside the for loop, and it's going to work in the same way. In this example, we have used a for loop to iterate over the fruits list. The loop variable fruit takes on each value in the list, and we print each fruit. The range function is often used with for loops to generate a sequence of numbers. So let's explore how that works. We will say for number in range 1 to 4, print, let's use an f string in here, let's say number, and we can say number. This one in here, the element indexer, and I'm just going to make it work, and we can see that number 1, number 2, and number 3. In this example, we have used the range function to generate a sequence of numbers from 1 to 3. The for loop iterates over this range, and we print each number. Okay, now we can talk about the while loop. The while loop is used when we want to repeatedly execute a block of code as long as certain condition is true. Let's explore a basic example. Let's say that count equals to 0, and I'm going to say while count less than 3. I will say print f string again count, and I will give the count in here. So what I'm going to do in here is I will say count plus equals sign 1. So when I run this, you are going to say 0, 1, and 2. So it works as long as count is less than 3 and count is 0 at the starting point, like in here, and we print that value, but after that we add 1 to count. So it's increasing in every loop, and we get the 2, and we can't get 3 because now there is no equal sign. If we do that, it will also print the 3, and we need to reassign this also, but let's delete this and make them rerun. It works only 3 times because we are increasing it by 1 every time. In this example, we have used a while loop to repeatedly print the value of count as long as it's less than 3. We increment count within the loop. Sometimes we want to control the flow of our loops using break and continue statements. Let's see how they work. By the way, we are using lists like numbers 1, 2, 3, 4, 5. We are going to cover the lists and other data types in our forward video processes, but I'm just using them for giving examples. This means that we have brackets for creating a list, and we have 5 elements in it, like 1, 2, 3, and 4, and 5. They are all our elements, and I'm just using them because it's going to be clearer to cover these concepts with lists, and we will cover what are they in the further processes of our course. Knowing only the list is created by the brackets, and we have 5 elements on it. It can be also strings and multiple random things like apple, 2, 3, cherry, 5. This is also a way to create a list, and we will cover that. Okay, let's give the same example, like create the list like numbers, and we can say 1, 2, 3, 4, and 5. We have 5 elements in it, and if we want to reach to them, we can say numbers and bracket. Let's say we want to reach to the first one, we can just say 0, and we can get the 1 because our first index is 1. Great. So we will cover the lists later on, and we have the numbers list. Like you can check the type of numbers and you will get list. Okay, let's talk about the break and continue. Let's say for number in numbers if number equals to 3, break, and then print f string number and number. So what it does is it exits for loop when number is 3, and it goes over 1 firstly, then goes in second firstly, and when it comes to the third element, the second index, it quits the loop because number equals to 3. This if statement works on that scenario. Like we inserted an if statement in a for loop in here. So if you want to give an example to the continue, we can say for number. In numbers, again, we are going to loop through this list. We can say if number divided by 2 equals to 1, continue. There's a typo. And otherwise we will say print f number It just kept this 2 in here because 2 divided by 2 is 1. It gets caught by this condition, and we just skip that with continue keyword. So break for exiting the loop, continue for skipping that, and keep going on. Let's do an example with conditions and loops. Like let's loop through a string. So let's say word is going to be equal to the Python. And if you write a for loop on this, it will iterate through P, Y, T, H, O, and N. So we can say like for character in word, we can say character dot lower, and we can print this. Here we get the Python in correct order, and we can also say upper after character, and we will get all uppercase letters in this scenario. So if we use for loops on strings, it iterates over every character. Let's talk about indentation. We can think it like spaces before codes, like this print statement have 4 spaces, and I give the space with tab. You can both use tab or space. You can press tab for giving 4 spaces. Python relies on indentation. Let's dive into the details of this unique feature. Indentation is not just a static in Python, it's a fundamental point of syntax. It's used to define blocks of code such as those within loops, conditional statements, and functions. And we already saw examples like inside the for loops, we give indentation for spaces in here, like in the both loops and conditions. Like I'm going to if statements, you can see that we are indenting here, we are nesting this if statement, and we use indentation. It's a really crucial thing in Python, and let's do examples with this. Let's say if true, print this line is indented, and also print so is this one, and we can say outside of this condition this line is not indented. So I'm just going to make this run, and if I say false, we will see that this 2 is not going to work because our condition is false right now. So it will only print this one since it's not indented. But if I say true to this, you'll see that all of them is going to work. Mixing spaces and tabs or having inconsistent indentation levels can lead to a syntax error. So we don't need to do something like if true, and we can say like print this line is indented with spaces, and we can say like print this line uses a tab which is not consistent. They need to be at the same level. Like if I press tab in here, it's going to work, but I used space, 8 spaces in here. After this if enter, I used 4 extra. We generally don't do that. So we need to check the indentation levels. Let's do an example for loops, like for index in range 3. Let's also firstly print this for remembering it. Print index and we get 0, 1, 2. And let's say print this line is inside the loop. And let's say print so is this, so this is 2. And we can say print this line is outside the loop. Also, let's make this run, and we see that it repeats 3 times this because it's inside the loop. It's going to loop through this 3 times and it prints the outside thing at the end. Let's talk about lists, tuples, sets and dictionaries. I showed you lists like with brackets and 1, 2, 3, 4 example, but we are going to talk about it more right now. We will be using them a lot when we are coding in Python. Understanding these data structures is crucial for effective and versatile. Let's start with lists. A list is a versatile and mutable data structure in Python. It allows you to store and manipulate collection of items. Let's create a list like fruits, and it can have values like apple, I'm going to store strings in it, banana and cherry. So we have 3 elements. For defining every different element, you can say this comma in here and then create a new element. Like you can insert the variables too inside the lists. Like let's say apple is going to be apple, and you can just use the variable. It won't raise an error in this scenario. It can store variables, integers, floats, strings, any type of data. And here is our fruits list. So let's access to its elements, like let's say first fruit, and let's save it like fruits, and we'll get the first one, the apple. So in Python, indexes start from 0, so we will say 0. And let's print this first fruit, and it's apple as we can see. Also, let's get the last one, like last fruit. And we need to use fruits 2 or -1. And we can just access to this with last fruit. Remember that if you want to go back to the last element and go from right to left, we can use minus. Let's do slicing in the list, like fruits can be like 1 to 3. Remember this bracket and the operations from the strings, they are same. We can check the type of our list, like type fruits, it's going to be list, and let's get the list again. So let's see some more methods, like we can say fruits.append, and we can say grape, and it's going to add the grape to the list like this. And if you want to remove an element, we can say fruits.pop, and let's say we want to remove the element with the index number 2, so it's cherry. And let's call the fruits again. You will see we have 3. We just added grape in here with append and dropped cherry in here with pop method. And in these examples, we have created a list of fruits and demonstrated various operations such as accessing elements, slicing the list, modifying elements, adding new elements, and removing elements. Okay, great. Let's talk about tuples. A tuple is similar to list, but unlike lists, tuples are immutable, which means that we can edit the lists and we can't edit the tuples. Once a tuple created, their elements cannot be changed. Like in lists, we just added grape in here and we dropped cherry in here, but we can't do that in tuples. So let's create a tuple. So what's the difference on creation is, let's say dimensions, and we need to use normal parentheses after this instead of brackets. So if I just say 10, 20 and 15, and I can change its elements right now, but we can still reach to them. Like we can say dimensions, and let's say we want to reach to the first element, I can say 0 and I can get 10, and we can get the like last element like this. There's no problem on accessing the elements, and we can just check the type of dimensions like this, and it's tuple. Tuples are useful for situations where you want to ensure that the data remains constant throughout the program. Okay, great. Let's talk about the dictionaries. A dictionary is a collection of key-value pairs, providing a flexible way to store and retrieve data. Okay, let's talk about them. We can create dictionaries with curly braces like, let's say, students, and we can say curly braces, then we can say name, and we need to use this after that, and we can say, let's say, Alice for the name. And after the comma, we can say age, and we can say 22. Then we can define like major, and actually it's a student, not students. For the major, we can say computer science, and we can say is student, and it can be true. So when I call student again, we will see that we will get a dictionary like name and its value Alice, age and 22, major computer science, and is student true. So let's check the type of this. It's going to be a dictionary. It enables us to store keys and values together, and we use dictionaries a lot when we are programming in Python. So how we can access its values, like we can say student, and we can, after that we can say with brackets name, so we will get Alice, and we can do like student age, and it will return 22. If you want to modify a value, like you can say student age, and let's make it 30. So when we call the student again, you will see that our age is going to be 30. And let's say we want to add another thing to here. We can say like student, and we can enter the new data point we want to create, and we can say like A. And when we call the student again, we will see the grade 2. And if you want to remove that, we can just say removed major, and we can say student.pop major. And let's call the removed major. We can see that computer science is removed. And we can call student. We won't see the major right now. Great. In this example, we have created a dictionary representing a student. We have demonstrated how to access values, modify values, add new key value pairs, and remove key value pairs. So let's talk about sets. A set is an unordered and mutable collection of unique elements. It's useful for tasks that involve testing membership and eliminating duplicate entries. For defining sets, we will say like colors set, and we will open curly braces again, but this time we won't give key value type of data. We are just going to create data like tuples and lists. I will directly say the value, and then I will use comma like green. Also, you can give integers like this too. I will say red, and I will say yellow. We can call like type color set, and it's a set. As you can see, we can get the length of this. Also, we can get the length of the lists and tuples. For checking a membership, like we can say is green here, and we can see like green in color set. So we have green in here, so it's going to return true. And let's get the value of the is green here. It needs to be true. Great. Now we are going to talk about a really good feature of Python, which is named as list comprehensions. List comprehensions provide a compact way to create lists, making your code more expressive and readable. List comprehensions allow us to create lists using a single line of code. They are concise and often more readable than traditional for loops. So let's start with a basic example. We can say squares, and we can create an empty list. Then we will say for number in range 5 squares append number in the power of 2. We need to use dot after this, and I will just make it run. Also, let me show you the output of this for loop. Normally I will say print number, and you will see that we will have 0, 1, 2, 3, 4, 5. If I do this, we will see that 1, 4, 9, like this. Great, so we are just adding them into our list like in here with append method. Like in every iteration with the append method, we add a value like we add 0, the power of 2, 1, 2, 3, 4, 5, and we add them into the squares list. We created an empty list, and by using the append method, we add the number in each iteration to this list. So in this example, we have used a traditional for loop to create a list of squares. Now let's do the same using a list comprehension. So I will say that squares list comprehension, and it's going to be like number and this for number in range 5. It's its syntax. So if I run this and call this, it's going to give the same result, just like the for loop, but in a single line, and it looks really readable, right? When you get used to this, it's a really nice feature and it's commonly used on Python programming. Okay, let's talk about nested data structures. Nested structures such as lists of lists or dictionaries of dictionaries allow us to represent complex relationships and hierarchies in our programs. One common form of nested data structures is a list of lists. This structure is particularly useful for representing matrices or grids. So let's say matrix, and we can say like we are going to open a list with brackets, and then for the first element we are going to open a new list, and we will say 1, 2, and 3. So in this side we have an element for the main list, and our element have 3 elements inside. So we have 2 lists in here, and I'm going to create a new one like 4, 5, 6, and I'm going to create a new one. Let me open up a space for that, for a clear vision. 7, 8, 9. So we have 4 lists in here, 1 main list and 3 in the elements. So I will just make it run, and I will just call the matrix. You will see that we have 3 different lists inside the main list. If I get the length of this, it's going to give me 3, since it has 3 elements. Like this. Great. Now we can access to its elements like matrix. Also, let's just delete this. If we want to reach to the first element, the second element, I'm sorry, this one, and I will just run this here. And if I want to reach to this 5, I'm going to say 1 again. I'm just going to add another bracket. And here we have 5. We firstly reached this, after that we reached this. In this example, we have created a list of lists representing a matrix. We can access individual elements using double indexing, where the first index refers to the outer list and the second index to the inner list. Working with nested lists also provides modifying and adding elements. So let's say we want to change this 1 in here, and we want to make this 99. So we can say matrix to first index and the first index of it. So we will say 0 again. Remember, indexes starts from 0 in Python. And let's firstly reach to that. Here it is, and let's set this to 99. And when I call the matrix again, you will see that that value is going to be changed. And we can add a new row, like let's say new row, and we will say 10, 11, 12. And we can say matrix.append, just like in lists. We can say new row, and we can call the matrix again, and you will see that 10, 11, 12 is going to be added up. In this example, we have modified an existing element in the matrix and added a new row to the list of lists. This showcased the versatility of nested structures. Another powerful form of nested data structures is a dictionary of dictionaries. This allows us to create a hierarchical structure with key value pairs. So we can say like students, and then we can use curly braces for creating a dictionary. And let's say like Alice, and we're going to open a dictionary again, and we can say like age equals to 22, and major is mathematics. And we can just add a new one like Bob, and we can say age equals to 25 and major equals to economics. and let's call the students dictionary. And if you want to access to the Alice's age, what we can do is we can say students Alice, and after that we can say age, like this. In this example, we have created a dictionary of dictionaries representing student information. We can access individual elements using multiple key indexing. Modifying and adding elements in a dictionary of dictionaries follows a similar pattern. Let's see it in action, like let's say students Alice and age, and we can say it like 25, and after that when we reach to this element we will see that it's 25. And let's also update this one, and let's add a new student like new student, and it's going to be age, let's say 20, major physics, and we will say student, let's say Charlie, is going to be equal to the value new student. So when I run this and call the students again, we will see Charlie too. In this example, we have modified an existing element in the dictionary, just like in here, and then we added a new student to the structure. Python allows us to combine various nested structures to represent even more complex relationships. So we can just do like copy this entire thing, and after that we can say people, and we can open a list. Then we can paste this dictionary in here. Also, let's fix this. Great. So when I run this, we will see that we will have people, a list, and we can check type of this. It's a list, but we can take the first element of the people and check the type of this, and we can get the first element of this dictionary like 0 and 0. Now you will see that we will get an error because this one was a dictionary and we need to write it like Alice. And after that we will get age and major in here. In this example, we have created a list of dictionaries representing people. We can access individual elements using both list indexing and dictionary key indexing, like this one in here. Great, let's talk about functions. Functions allow us to encapsulate and reuse code, making our programs more modular and readable. Defining a function involves specifying a block of code that performs a specific task. So let's start with a basic example. We have the keyword define, def, and after that we will give the function name, and we are going to open parentheses. And let's say like when we call this function, we want it to print hello Python lovers. Okay, something like that, or we can just write hello. So after defining this, we can call this function in our program like this, just like the type of print function. We can use that. In this example, we have defined a simple function named greet that prints a greeting message. The function is defined using the define keyword followed by the function name and parentheses. We then call the function using its name and parentheses. Functions can accept parameters, allowing them to receive input values. So let's explore how this works. Let's say define greet person, and let's add name in here, and then we will say print f hello, and we will say name. So let's talk about this. Here we give a name in function, and then we use this given name in here. It's not a variable, we just give it when we call function, and we use it in here. Like, let me show you, greet person, and I'm going to write my name, and the name is going to be my name, and we can also change this to Bob, and you will see that the name is going to change. It's not a variable, it's the input of the function. In this example, we have defined a function named greetPerson that takes a parameter name and prints a personalized greeting. When calling the function, we provide an argument for the parameter, such as greetPerson Bob. Functions can have default parameter values, which are used when an argument is not provided. This provides flexibility on function calls. Like we can say define grid with default, and we can say name is going to be equal to the Charlie, and we can say print hello name again. And here, if I don't give a name to function, it's going to give like. Also, we need to use it with parentheses. If we do that, we won't get this print message. We will see that hello Charlie, but we can give it name inside like Bob, and it will print the Bob this time. But if we don't give anything to function, it will just print this default thing, Charlie, like this. In this example, we have defined a function named grid with a default parameter value for name. If no argument is provided when calling the function, it uses the default value. Functions can return values too, allowing them to produce a result that can be used elsewhere in the program. So let's define a function like square and give number inside, and let's return. We have the return keyword for returning values, number squared version of the number. So when we call this, it's going to give an error because we need to give an input, and when we say 5, it will return 25. Great. So we can just store this like result square of 5, and then we can use this in our programs like result. We will get the 25 again. So in this example, we have defined a function named square that takes a parameter number and returns the square of that number. We call the function and use the returned value in the program. Functions can have multiple parameters and return multiple values. Like we can say define calculate rectangle area, and let's say we want to give length and width. And after that, what we can do is, also I wasn't going to make it run, so I can just say clear cell outputs from here, and I will say area is going to be length multiplied by width. Also, let's add something like parameter is going to be 2 times length plus width. Actually, I made a typo in here. I'm just going to change that, and we will return area and parameter. So also now we are going to see a different variable creation, like we can say area and parameter, and we can say calculate rectangle area 4 and 6. So when we run this, we will get values for both area, the first one, and we will get a value for both parameter, the second one. You can create variables like this, but if you mix the order of them, it's going to change. So the order is really important on this too. Like if I change their position, you will see that their values are going to change like this. We don't want that. Okay, let's see a function with variable number of arguments. So we can say define calculate sum, and regardless of the number entry, like user can enter 20 numbers, we will say arguments in here. We will say total, and we have a function like sum for getting the sum. We will say arguments, and we will say return total. So here we can say calculate sum after creating this and give 1, 2, 3, 4, 5, 6, 7, 8 and a lot more, and it will return the sum of this. You can just delete some of them and it will work the same, like this. In this example, we are defining a function named calculate sum that accepts a variable number of arguments using the argument syntax. This allows the function to handle any number of input values. I'm just repeating everything after each operation for this course to be more informative. Let's talk about lambda functions. Lambda functions are a concise way to create anonymous functions in Python. They are often used for short, one-time operations. We can define them in one line. Like we can say square, and we can say lambda x, x, and 2, like this. And after that, we can just use like result is going to be square 4. Just like the regular function. Here it is. It works exactly same as the function we defined. Let's talk about modules. In Python, a module is a file containing Python definitions and statements. These files can define functions, classes, and variables that can be reused in other Python scripts. We have a keyword import for that, and we are going to, let's say, import the random module. And after that, we can use its attributes, functions like I will say random, and I will use random integer, and I will give it a range of 1 to 10. Also, you can see at the upper side, it returned random integer in range, including both endpoints, and it shows the inputs of this. And I will say enter, and it just returns a random number. It will change every time when you run the cell, and it's a nice module that you can use a lot in your programs. After the import of the module, you can use its attributes like this. In this example, we have imported the random module using the import keyword. The random module provides functions for generating random numbers. We use the random integer function from the random module to generate a random integer between 1 and 20. You can also import specific functions or classes from a module, reducing the amount of memory your program uses. Like you can say from random module import choice and shuffle methods. And after that, after this import, you can use this too, but you can't use others if you import it like this. Like let's say my list is going to be 1, 2, 3, 4, and 5. And if you want to make a random choice from this, we can just say random.choice or directly choice. Since we imported directly, we can say my list, and it will give it a random choice from this. If you do like random.choice, random.random integer, you will be using this. If you directly write choice, you will be using this because you are importing this one directly. And you can use shuffle like this, and it's going to be like, it will change its order. You can just print this for seeing. It will just update the original list. Like when you do shuffle, it won't work with print because it will return none. If you use shuffle my list, it's going to be shuffled, and you can just call this again, make this run again, call this again. It's just going to change the order of your list like this. Okay, so in this example, we have imported specific functions from the random module. We use a choice function to pick a random element from a list, and a shuffle function to randomly rearrange the elements in the list. Sometimes module names can be lengthy. You can use aliases to create shorter names for modules, making your code more concise. So what I'm talking about is, I will say import random, we have a keyword as, and we can say R&D. And after that, I can just use random as like R&D. I can say R&D, and then I can use its features like random integer 1, 5. So here it is. If I import it like this with as keyword, I can use R&D after that. In this example, we have aliased the random module as R&D. This allows us to use the shorter name R&D when referencing functions from the random module. Python comes with a variety of built-in modules that provide essential functionalities. Let's explore one of them, the math module. Like we can say import math, and after that we can say math, and we can use its functions. Like you can just scroll in here and see. So I will say square root, and I will say 25. Also we can do like math.factorial 5, and we will get 120. Great. In this example, we have imported the built-in math module and used functions like square root to calculate the square root and factorial to compute the factorial of a number. Great. Let's talk about classes and objects in Python. It's going to be our last topic for this course. In Python, a class is a blueprint for creating objects. An object is an instance of a class, and it can have attributes and methods. Attributes are the characteristics, and methods are the functions. We will also talk about object-oriented programming. Object-oriented programming is a style of programming characterized by the identification of classes of objects closely linked with the methods with which they are associated. So you will understand better, it's just a definition, and we can start to learn about them right now. I will create a class we have a class keyword for creating classes. I will create a class as dog, and its syntax is like define. Then we need to use init in here. It's a common thing for literally every class. We will say self, name, and age. We need to use this self too, and after that we can just use like self.name is going to be name, and self.age is going to be age. And this is a characteristic of this, and we can just define a function like define bark, and we can say self, and we can just use print f self.name says wolf. Here it is. So we have a characteristic in here and method in here. So great. Let's talk about this. In this example, we have defined a class named dog. The class has an init method, which is a special method called a constructor. The constructor is used to initialize the attributes of the class. We have attributes name and age. Additionally, there is a method named bark that prints a bark message. Once a class is defined, we can create objects from it. Objects are instances of the class, and they can have unique values for their attributes. So we can do like dog1, and we can use dog class, let's say body, and let's say tree. The name is going to be body, like in here we need to give it in the same order. We don't care about the self in here. Name is going to be body, and age is going to be 3. And also let's say dog2, and we can say dog max, and we will give 5 in here. Actually, I need to add parentheses, not brackets. Great, it looks better. Now we can call these characteristics like dog1 dot name is body, dog1 age is 3, dog2 name is max, and dog2 age is 5. Now we can use this bark method with 2 of these, like we can say dog1 dot bark, and after that we will see the method bound method dog.bark, and if we add parentheses after this, we will see that body says wolf. This function, like let's delete them and see it clearer, and if we say dog2 dot bark, we will see that max says wolf. So this is how we create classes and use them. We can talk about inheritance and other features of the class, but I'm not going to include them in this tutorial for this to be simple and not more complex. If you want to just see them, you can just visit my YouTube channel, and I have a full video of classes. It was like a 7 minutes, and I show everything about classes on there, so I'm not going to include in this tutorial because it's going to be literally complex if I add them. So with the class definition, we can finish our course. It was all from me for this video, and thanks for watching if you watched this far, because it was a really long video. I think it's more than an hour, and thanks for watching. You can like the video, share the video, or subscribe to the channel for supporting me. I'm creating content about Python programming and data science, and I'm trying my best on providing valuable content, and you can just check the videos if you want. I have a full data science learning playlist with the name Learning Data Science in 2024. It has like 20 courses inside of it. You can just check the playlists from the channel playlist page, because I have a full playlist of Python videos that are Python projects and Python tutorials. I have a full playlist of data science projects I teach on the channel. You can just check them for seeing more informative videos. If you are learning programming, I'm pretty sure that you can find valuable content in the channel playlists page, so you can just visit that. Thanks for watching again, thanks for spending your time in this video, and have a great day. See you in another course.